Okay, let's just take a couple of minutes to look at a bit shift program that I've got written here, okay? And it's a little bit of a modified from what my students did in class. And I've got a bit shift left and I've got a bit shift right, okay? So the forward switch is going to cause it to go left, and then the reverse switch is going to cause it to go right. And they're interlocked here, so I can only go forward or I can only go reverse because the switch is interlocked with the other one. So where they're going forward or reverse. So when I push the forward switch or the reverse switch, it doesn't matter if I'm shifting left or right. Basically, I'm going to advance a counter. So I'm going to get a counter to advance each time, okay? And then I want to put some data into my bit shift left or my bit shift right. So I just put like a limit test here. So as this counter advances, it doesn't matter which, if I try and go forward or reverse, it doesn't matter. The counter is going to go up, and it looks like the counter is going to be, this light here is going to be false the first time I push it because it'll go to 1. The second time I push it, it'll go to 2 and 3 and 4. But finally, when I get within this limit here of 3 to 8, 4, 5, 6, during those times when I'm pushing either forward or reverse, I'm going to get this light to be on right here, this present light, because this is within the limit. Okay, why am I using that present light? Well, that present light is either off, which is 0, or it's on, which is 1. So if I look at my present light source bit, I'm using it for the bit shift left and the bit shift right. So I'm either going to be pushing a 1 into my array if the light happens to be on between 3 and 8, or at other times I'm going to be pushing a 0 if for some reason it falls lower or higher than this. And same for my bit shift right. Okay? So the first thing we want to do is we want to take a look at our tags, and here's my bit shift array right here. I'm going to monitor them. Okay? So what I've got is some number in there. I don't even know what it is. I can just make that a 0, and basically that zeroed everything out here. Okay? But I want all these to start with a 1, so I could come in here and highlight that and type 1 and enter, then 1 here. Well, that seems like a big pain, right? I want all these to be 1s because I want to show you what's going on. So maybe the quickest way to do that is to change this to binary and click this and go 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1. You get that? You get the gist of it, right? So when I put the 1s in there, then all of a sudden this gets all populated with 1s. Okay, I can go back and look at this at some decimal. That's the binary for this, but basically I just wanted this to be all 1s. Okay, so I'm going to go back to my main routine, and what I'm going to do is I'm going to bit shift left. Okay, so I'm going to push the data 0 button right there. Okay, so my counter goes to 1. I'm holding the button down, and because 1 doesn't fall within this, that light is 0. That means that 0 is getting pushed into supposedly the bit shift left. So let's go and look at the parameter and local tags, and I'll monitor this again. Remember, I made all these 1s, and look, yeah, now there's a 0 there. So what I'm going to do is I let the button up. I'm going to push the left again, and another 0 gets moved in because my counter's only at 2. It's less than the 3. And I am bit shifting left. So that's different than a SOOK 500 where the numbers are laid out, in a word. You might expect to see it something like this, where the word is shifting from left to right or from right to left. From here, the bit shift is headed in this direction. Okay, so I'm going to push it again. And now I've got a 1 coming into there, okay? And I am bit shifting left because this 1 came in here. And once again, in a SOOK 500, the word would be laid out horizontally instead of vertically. And so the 1 went in there. How come? I'm going to go back to my main. I'm holding the button down still because I'm within the limit here. And so now the light is going to go. So supposedly for the next 4 times when I push this, I would be getting 1s to come in there. So let's try it again. So I'm going to push the button again. There's the next one. A 1 came in, and the 1 shifted left. Push the button again. A 1 shifted left. Push the button again. A 1 shifted left. Am I at 8 here? Let's see. Push it again. Oh, a 1. I got a 1. I'm going to guess that's my last 1 coming in. I'm going to push it again. Oh, I'm still getting 1s. Let's see. I must be reaching that limit that I said. There we go. There it is. So my counter now must be at 8. So now I've got 0, 1, 1, 1, 1. I pushed in 3, 4, 5, 6, 7, 8. Yep, that's right. So there's my ninth 1. If I come back here, my counter is at 9. Okay, that makes sense. So the next thing to notice is that the length of this is 8. My bit shift left, my array is 8. So if I come and look at my local tags again, I monitor my tags, I see that I am right here at this point. Okay, so now when I push again, I'm going to push in a 0, and it moved a 0 in there. I'm going to push it again, and it pushes in a 0 again, and so I keep pushing down. I'm going to push it again, and it's pushing this data down into here. Okay, but because let me push it one more time. Okay, and so I just pushed it 1, 2, 3, 4, 5 times. Okay, but the issue is that because my array is only of a certain length, the numbers that I now have down here, well, they're going to be gone. Okay, so what I'm going to do is I'm going to come back up here, and I'm going to now do the reverse switch, which is data 5. All right, I'm going to look at my PLC here, digital input 5. So when I push this digital input 5, this counter is going to keep going. So, and because it's not within the range there, it's going to do a 0. So I'm going to get a 0 pushed in here, okay, and it's going to be shifting the other direction, and that 0 is going to go in at the end of the array. So let's watch these numbers here. We got these 1s right here. I'm going to go ahead and push the number, and what did it do? It pushed a number in right there. Okay, so I'm going to go ahead and push it again. It's pushing it in again. It pushed another 0 in. How come it didn't push it in here? Because we had a length of 8, which was 0, 1, 2, 3, 4, 5, 6, 7. That is a length of 8. So this one fell off the list. Okay, and if you come and you look up here where it's coming, right there, you'll see that this one fell off, and so we can't get it back. So when the next 0, it comes in right here. So there's the 0 going in there, and everything's shifted right. I'll push the 0 again, everything's shifting right. Push the 0 again. So it looks like I'm getting my 0s all the way up here. Coming up. And once again, that one was gone. I couldn't do anything with it. Okay. So hopefully, let's see, one more thing I wanted to take a look at. In your lab, you had a rework situation where you had a failed part, okay? And so what we were doing with our failed part was we were going to latch or unlatch something and move something here. So if I reworked a part, I would push digital input 8, which would cause a latch, and that would return a 1 into this, and digital input 7 unlatches it and returns a 0 into 10. So if I go into my array at dot 10 and check my monitor tags, array dot 10, I do have a 0 there because before it had a 1 in there, I pushed that number into there, and it went away. So what I'm going to do is I'm going to go ahead and bit shift right again, and let's get another 1 back in there. So remember, these 1s are shifting. I keep shifting these 1s up, but they don't ever go into my array up here, the array that I kept, because my length was only 8. So even though I'm shifting this 1 up, it's not doing. But anyways, I got a 1 in here. I had to rework the part. I believe it was digital input 8. Let's see, let's try that again. It might have been digital input 7. There's my rework. Okay, so I had to take that part off, and then digital input 8 would push a part back in after I shifted it. I pushed the button and it put the 1 back in there. Okay, so basically I put a 0 there. It went down the line. We reworked it, and I push the button to put a 1 back in there. And that was pretty much straight out of the textbook, so hopefully that made sense there. That the failed part would turn off the light, the unlatch it, put a 0 in there, indicating that it was clear, and then we would shift it. And then when I push this rework button, it would hit shifted from 10 to 9. I would push that, and I would put a 1 back in there, saying that, hey, I took the part off here, and now I put the part back on 1 station down. Okay, so that's kind of the difference between the bit shift left and the bit shift right as we look at it on between the SLC 500 and the control logic.